Hello, all, and thank you for joining me in this introduction to the statistical programming language for the social sciences. That stands for, or the acronym that is SPSS. And I will be doing an introductory workshop about the basic features of SPSS. And for this demonstration, I intended to download an Excel spreadsheet from the internet, import it into SPSS, talk about the syntax editor, generate some statistics, perform some data cleaning, and export my results. So here I am set up on the Sizer servers. I am a statistical consultant for the Cornell Institute of Social and Economic Research. Our acronym is Sizer. And you don't necessarily have to be on your or these remote resources, which if you are a Cornell member, you can have access to for free and connect to at any time in the day, at any place, so long as you have internet access. But this workshop can be replicated by all users that have access to SPSS, whether that's through a personal license of their own, or maybe they're in a lab or a classroom, a library that has SPSS pre-installed. And you also need internet access to download the dataset. But that is all the introduction I believe I require. I'll get right into the programming language. I open SPSS, and it'll take me a little bit of time to load this application on my servers. But here we are, and I'll briefly mention SPSS as it is right now. This is the data viewer, very similar to Microsoft Excel. I can enter my data here just like I would with Excel, and it creates variables for me in the form of columns and observations in the form of rows. And SPSS is very similar to the two other programming languages, Stata and SAS, and they all play to the beat of the same drum set, but each of them have minor differences between the three that make some more suitable in certain areas and others better in other subjects. So it's really just preference. Which programming language do you want to use? And which one do you like the most? This SPSS, what makes it differentiate from the other two that I just mentioned, is it has a great data viewer that I'm looking at right now. I can scroll down and look at all of the data, all of it, at one time without having to submit a command. And what's also great about SPSS is the menu. And I am more of a keyboard typer with my commands. I like to use the keyboard, not so much on the mouse. But with SPSS, they have a great and fantastic resources in the menu that I can use to create my results, but also export the code, the equivalent commands that would accomplish those tasks. And I see there could be a lot of learning just by navigating through these menus, and you never really know potentially what you need until you see it in the menu. And that would be the data view, followed by the variable view. See, I had already typed in some values before, so it displays to me the type of the variable and basic information. But I want to get rid of that because I wanted to download a data set from the internet and use that. So I'll open a web browser. Not that, but a web browser. And I will navigate to google.com. And what I will type in and search into Google is sample Excel data. And I want the data from the contextures link. So I'll open up that link, and after scrolling down just a little bit, I see the option to click on this link and download the data set. Now, in theory, I could highlight all of this data and copy it and paste it into SPSS, but that is extremely poor research methods, as the reason why, well, a big reason why I'm using these programming languages is so the work that I do can be replicated. I can create codes and commands that other researchers can run and duplicate the work that I've done. Furthermore, copying and pasting into here would be not efficient at all for very large data sets, as you could be scrolling, spending minutes just trying to highlight the entire thing. So please never do that. It is not suggested. But I will choose to download the file, which is a zip file. I have to extract the contents in order before I'm able to import it into SPSS. So I have the option to save this file, and I'm going to want to remember where this file is saved, and it will be different for all of you listeners. The most likely cause is the file will go to the downloads folder. So I will navigate to my downloads, and I see sample data. Hey, that's the zip file I'm looking for. I click on it once to highlight it. I right click on it so that I can extract the contents. I'm going to select extract all. And I'm going to create a folder titled after the work I'll be doing in the programming language today, SPSS, in my downloads folder. So I extract the files, and I want to follow up by entering that folder that I just created to see there's my Excel spreadsheet. I've done all the necessary prep work. I have the data set. It's extracted and downloaded to my filing system. I have SPSS open and ready to go. But first, before I open or attempt to import this into SPSS, I want to open this data set in its most original format. In this case, an Excel spreadsheet. I double click on it and I open it up. However, I do suggest any other type of file, if it's not an Excel spreadsheet, to attempt opening it using a notepad application. Even a CSV file, which stands for comma separated values, by default opens with an Excel spreadsheet, but sometimes the formatting can change from converting a CSV to an Excel spreadsheet. You typically want to open all data files, original data files, using a text file or a notepad application. But in this case, it's an Excel spreadsheet, so I open it up in Excel. And what I saw online was just the data. And when I open up the spreadsheet, I didn't realize there'd be 4 sheets. I thought there'd just be one having the data. So this is helpful. I know before the import that the sales order sheet will contain my data, and the rest of them I can ignore completely. Good statistical principle to open up your data set before importing. And now I'm ready to bring into SPSS. And this is where I'll talk about the menu, talk about the code and the syntax editor. SPSS menu is the cat's meow. It's tops. So I go to File, Import Data, and my option of Excel. Now this is where I have to remember, oh, where did I save that data set? Where did I download that file? Well, I saved it to the Downloads folder and a subfolder within Downloads called SPSS. And there is my Excel spreadsheet. Now, I'm going to explain these options. The Open option will proceed me through the wizard and open the data set as I want. And the Paste option will do all of those steps, the equivalent of importing the data set, but rather it will create code for how to do that process. Now, SPSS and all programming languages, you want your work to be documented. And you want it so if I send this to other researchers that they can use it. And there are many, many ways to accomplish the same task in programming. And I'll go over a few of them just about pasting and tracking my work. But I'll start with this Open option just to get the data in. Now I remember from looking at the data set in Excel that sales order is the sheet that I wanted. And by default, the options are set pretty well for me. I want the variable names read in, or the first row read in as variable names. I'm provided a little preview at the bottom and everything looks completely in order. So I don't need to fiddle around with this anymore. I'll press OK. And my data set is now here. I want to check out the data view, and it's just like I had seen it in Excel. And some variables contain dates. This variable is a date variable. These variables contain text. Text is acceptable in this programming language. And so are numbers. Now I want to jump back for a second, if I may. You see that in my output window here, this is where I have a copy of the command that imported that data set. Now I'm going to want this. So I'm going to double click into where I see this code printed. And I'm going to highlight it all and copy it. I'll go back to my SPSS data view, up to File, New, and Syntax. This is my program file. This is where I'll be keeping track of all the work that I've done. And now I'm just going to paste that command into there. See, this is why I think I really like using the menu in SPSS rather than typing like I do in other programming languages. For the get data, it's cool in this syntax editor that the codes are color coded. So I know typically if something's going wrong, but get data is the key word for importing a data set into SPSS. And most all SPSS commands, if not all of them, begin with a keyword. And you know that it's a keyword, typically a good sign, when it's colored blue, blue-colored font. Get data's blue. See, this is why I want to use the menu rather than the typing this command out in the syntax editor, is all of these subcommands have to be typed exactly as they're presented. And it'd be tough for me to remember type, then file, then sheet, then cell range, and all of that information. So I just let the menu do the work for me. I also note that an SPSS command ends with a period. So this get data command really spans all the way to this 8th line until it encounters a period. What's also important is this execute period sign, which is placed after get data. It tells SPSS, hey, run the above command. Make sure you actually do this. Now I'm going to add a new line at the very beginning. And starting this new line will be an asterisk. And this is the character to create a comment. Comments are great. Excellent programming facet. I start a comment with an asterisk at the beginning of the line. I end a comment with the next occurrence of a period. That's why this whole command's been turned to gray colored font. Gray colored font means a comment, and it's looking for the next occurrence of the period character. And me, as the organized programmer that I am, I always like to include a comment above the command that I just performed. A quick little comment reminding myself or other researchers, if I'm sending them my files, what this command's going to do, such that if I refer to this file a couple years in the future, I don't have to navigate through the actual command itself and try to understand it. I can just look at the note that I left myself right above it. Import data. I end it with a period. And just to get the ball rolling, I'll save this syntax file right off the bat, since I'll be making changes to it continuously throughout this video. And I'll call this syntax work codes. Okay. So I've started my syntax window. I've got my data set imported. And I'm ready to move. The first thing I'll do is just do some variable inspecting. Look at these string variables. A string variable means characters, text for variables. I want to see the frequency counts for the region variable and the item variable. I go to Analyze. I go to Descriptive Statistics, and then Frequencies. I select Region and Item and bring them over to the other side. And I always like to look at all of these buttons on the side here. Statistics. Well, none of that really applies here because the variables I'm getting frequencies for contain text. Can't really have maximums of that. Let's look in the charts though. Yeah, I'll create a pie chart, I guess. And I'll look at format. The defaults seem fine to me. Whoa, look at this style. I'm just going to stay away from that. And Bootstrap is a more complicated statistics procedure that I know little about. So I don't have to worry about those buttons either, style or Bootstrap. But I want to test this frequencies command. So I press OK, and automatically my output window appears, and I get to see my output. 24 in the central, 13 in the east, and 6 in the west, followed by the frequency counts for the items. And here are the pie charts. And you know, I don't really like pie charts. So I want to go back to my frequencies procedure. Aha! SPSS recognizes the most recent command that I did with frequencies and assumes that I want to do the same thing. So it's pre-populated. This time, I don't like pie charts, so I'm going to make a bar chart of percentages. But rather than pressing OK, I'm going to say, I'm going to be satisfied with that command, and I want it added to my syntax window. And I'll just continue working. I'll press the paste command this time. Building off of what I said earlier, there's always more than one way to accomplish the same task in programming. And who am I to sit here in front of this computer and tell you how to code most efficiently, as everybody is unique and each individual prefers to do things this way or that way. You could create your syntax editor by copying commands from here and pasting them to your syntax window. You could create your syntax or log the work that you've done by using the paste option, which you see what I was just doing there got pasted to the bottom of my syntax file. It always gets pasted. However, using that paste option, it doesn't actually run the command. You see in my output window, this is still the frequencies from the previous time around, because I wasn't creating pie charts anymore. I was creating bar charts. I should see bar charts. When I go to this syntax window, I highlight my section of code that was created from the paste option. I press this little green plus icon, and that submits my commands. I see now we got bar charts. I like those better. I am ready to proceed, but first, I showed 2 ways of logging your work, and there's another way, and a lot of people like to, since this output window has the code and has the results, you can export this as, in my case, I would want to export as a Word file so that I can copy and paste commands and make my own syntax editor. So this method I would do by probably at the very end of my SPSS session when I'm about to hang it up for the day. But just for a demonstration, I'll say at the beginning, and that seems good for me. I'll press OK. And I want to open up my folder. There's my export of the output window. Now I could copy and paste commands from here, or I could just send this output to another researcher like, hey, look at the work I've done. But I'm ready to press on to the next aspect of this SPSS workshop. So I did frequency counts of the string variables. Now I want to investigate these numeric variables. So I go to Analyze, Descriptive Statistics again, and I go right into Descriptives. I'll take all of these variables, and these are just summary statistics like average, the minimum and maximum values, the variance, the standard deviation, just basic summary stats. So I press OK. I'll look at my output. I'll look at my output in the window just to remind myself that, yeah, this looks pretty good. I like this. I'm going to include this in my syntax editor. So I go back to the same spot that I was in. I was in the Analyze, the Descriptive Statistics, and the Descriptives. And just like the frequencies, SPSS recalls the last time I used this, and it pre-fills with everything. So I press the paste option. I go back to my syntax window, and I'm going to add a comment. Frequency counts, summary statistics. Oops. And now, next thing. So what I'm very interested in for this demonstration is this unit cost variable, along with this region variable. Now I see that region is a string variable that appears to have 3 layers: east, central, and west. Now I want to see, what is the unit cost like? The average unit cost, the spread of unit cost for each of these regions. That can be done easily. Back to my Analyze tab where I've been this whole time. Except this time I'm moving away from Descriptive Stats and I'm going to go to Compare Means. And I choose the Means option. Now my dependent list, that's my numeric variable. That's the unit cost. And my independent list is the region. I'm going to inspect these statistics like, right here I'm just creating the average, the number, and the standard deviation. I want to see the minimum and maximum values, and I want to see the variance and the skewness too. And all of that looks good at the moment. So I'll press OK to see my output and determine if I like it and if it is worthy to be added to the syntax file. I have 43 total observations. And I'm going to look at, for the central region, the average unit cost is 18. I'm going to say the unit is dollars, US dollars. For the east, it's $9. And for the west, it's 53. That's huge. And I also see that, well, there's only 6 observations in the west region. It's the smallest region, and yet it's got such a high average and a huge standard deviation, a measure of spread. And I tell you, it's probably because this very large value of 275. The overall average is 20. 275 is enormous. I would consider that value an outlier. And a very common statistical procedure is to remove outliers from a data set. That'll be part of my data cleaning process. I'll do that later when I get there, shortly. Right now, I'm still on looking at these averages for the region. Now, this is very interesting to me. I am going to perform an Anova test, very similar to a 2-sample t-test. However, it takes it a step further. A 2-sample t-test can only compare 2 groups. However, I'm presented with 3 groups. So I have to use an Anova test, an analysis of variance. And that's the null hypothesis for this test, is that all of these regions, the unit cost is identical. There's nothing telling me that one region is different from the others. And what I just said is my alternative hypothesis. At least one of these regions has a significantly different unit cost than the other two, or than another one of them. Now, the Anova test doesn't tell us which one, but it will tell us if any are different. I'm going to jump back to my data set, and I go to Analyze. Down to compare means, because I saw when I was looking at compare means, Way Anova test. Hey, that's what I want. I want the unit cost as my dependent variable. But wait, I wanted region to be here as my factor variable. That has the groups. It's not there. Duh. This is no problem. SPSS has a fix for this. And this is a big aspect of programming too. Problem solving, in addition to multiple ways of accomplishing the same task. Now, I can't yet do the Anova test. It looks like when I was in the menu for Anova, that the only variables that were listed were these variables that had a ruler icon next to them. Variables that had numbers. The variables with text were not included. Now, the region variable only consists of 3 layers. One being east, a second being central, and a third being west. Now, couldn't I just create a variable called, well, it'll be called region, but it'll be a numeric region, and where every single occurrence of east is denoted with the number 1. Every occurrence of the word central is denoted with the number 2, and west the number 3. Well, I can certainly do that in SPSS. I go to the transform menu. I go to recode into a different variable. I'm recoding the region variable from string to be numeric. And I want it to be in a new variable that I'm going to call region_n for numeric. And just a quick tidbit about naming variables in SPSS. It has to begin with a letter or an underscore. This is an underscore. And it can't contain spaces. So that's why I used an underscore instead of a space. And I'll apply a variable label to this data set. Numeric region, or to this variable rather. Now I always forget, but I have to make sure to press this change button to bring region_n up here to tell SPSS that region_n will be created. Now I have to tell, I can't yet press OK. SPSS is still waiting for me to complete this wizard. And I guess it just assumes that I need to click on this old and new values, meaning that what values in the region variable will turn into which values in this new variable. So I had just said, every time I see east, I want that to take a value of 1, and I add it. Every time I see central, and notice that I'm making sure that east had a capital E, central had a capital C, that is matching exactly to the exact character, what is presented in the data set to the left of my screen. Any slip up, any typo will allow that one field to not go correctly. I continue through that and I'm able to recode this. I press OK. Here's my code again from that command. I want to make sure that it actually worked. East there's a 1. Central, there's a 2. And down here where there's a 3, there's west. So the command went swimmingly. To make sure that it is in my syntax, I go back to the same spot I did in the menu. Everything's already pre-filled in of what I just did, so I just have to press paste, and it's in my syntax. I'm going to add a comment that says convert region into numeric variable. Okay, I think I'm ready to proceed, or at least ready to take a stab to see if the Anova test will work this time. Back to analyze, back to compare means, and one way Anova. I put unit cost in the dependent list, and aha! In the numeric region is present. I put that as my factor. I look at this contrast, and I look at this post-hoc test too. As I had said a little bit earlier, that a one-way Anova test, or any Anova test, they can tell me if at least one group is statistically significant from a different group, but it doesn't tell me which group. So if this is significant, and I'll say to, this is a very crazy statistic. Normally you keep it at a significance level of 5%, but I'm going to be very bold this time and say 20% significance value. And I'm going to take my Tukey test. So if I have a significant p-value for the Anova test, I know that at least one group is different from the other, but it doesn't tell me which groups. The Tukey test, along with these other tests, I've heard of the LSD, the Bonferroni, the Waller-Duncan, and the Dunette tests, but the Tukey ones I've used the most, so I'm just going to stick with that now. Now, I think I'm ready to, I'll look at the descriptive statistics too. I think I'm ready to check out my results. My claim, my assumption would be that the Western region would be statistically significant because such of a high average. Now, here are my results. And with a significance level of 15%, normally, normally with a 5% significance value, I would fail to reject the null hypothesis. But with my significance of 20%, I'm going to say that at least one of these groups is statistically significant. And I go down here to this section to find out which one. I remember 1 goes to east, 2 to central, and 3 to west. Now, the significance values in this table, the ones that are less than 20%, are the ones that are statistically significant. And that one is, in this case, the relationship between the eastern region and the western region. But hey, now hold the phone. I don't like how I have to remember that 1 means east, 2 means central, and 3 means west. I would like them to say east, central, and west. It looks way better. So I'm going to go back to my data set and back to my Anova test because I wasn't quite finished with that. I wanted to, oh wait, not the Anova test. I've got to first apply labels to this variable such that I'm essentially giving it a nameplate, a name tag. Whenever I see the occurrence of 1 in this variable, give it a name of east. It'll still be a value of 1, but it'll look like east in this data viewer and in the output, which is way better. And now this is a command, perhaps let's say, well, I don't know how to apply value labels. I know it's a thing, but I just don't know how to do it. There is so much learning, so much programming to be learned by searching Google. That's why I opened this fresh Google session and I type in SPSS value labels. Of course, there may have been a researching step to remind you that value labels are needed. And I'm going to type syntax too. This time, I'm not going to use the menu. I'm going to type out the command for the value labels. And this is good practice, as some features of SPSS, you can only type them out. Not everything's in the menu. So I scroll down here until I find, aha, an example of code. And I examine this syntax. It begins with the keyword value labels. It's followed by the variable name. And then I enter the number followed by the label that will be assigned to that number. Ends with a period and an execute period. I have all the information I need. I go to the bottom of my syntax, I type value labels, just like I'd seen, and it turns red, which is expected because SPSS is waiting for the occurrence of a period. And the red colored font is telling me this is an error waiting to happen. But you see when I put a period in, it turns blue. Hey! Of course, I'm not done with my command yet, so I'll add that at the end. The variable name, I'm not even going to risk it typing in. The variable name also has to be case sensitive, typed in exactly as it is presented in the data set. Region underscore N, in my case, with a capital R and a capital N. Then I specify number 1 goes to east, number 2 to central, and number 3 to west. I mark the end of this command with a period, value labels turns blue. I enter a new line with execute period to mark the end of that command. And I'm pretty proud of myself. So I'm going to highlight this and run the commands to see the work that I've done. I run the commands, I go back to my data set, and voila, it's still numbers. But I didn't get an error message. What I need to do is I need to tell SPSS that recognize value labels and display them. Bink. And there they are. Now I'm ready, finally, to go to my Way Anova and to complete the command, I believe. I look at the postdoc test. Everything seems good. And I'm going to press OK. Now this time, instead of seeing 1s and 2s and 3s, I see east, central, and west. And before I was talking about the Anova test and the results. If this confidence interval does not contain 0, so negative to positive contains 0, negative to negative does not contain 0, that group is significantly different. The east and the west. And we see it again, west and east over here. That command was good. The Anova test was great. I go back to where I was in the menu. It pre-populated it exactly the way I liked it. So I paste it to my syntax. I head over to my syntax. and I say Anova Test to compare unit cost by region. Now, I said at the very beginning that there are always more than one way to accomplish the same task. And I may have gone a little bit overboard with accomplishing this. Just to get the Anova test, I had to convert this string variable to numeric. I applied value labels so it looked nice, and I had to navigate through the Anova wizard 2 or 3 times until I actually got it the way I liked it. There's another way to do the Anova test, and it's much quicker. I can go to Analyze. I go to the Descriptive Statistics, or no, I go to Compare Means and Means, like where I was before. Earlier in the options, there's this checkbox for Anova table and ETA. Yes, it was that easy just to check that box to do an Anova test. And I didn't have to go through the step of converting region to be a numeric variable, because that was acceptable in this case. So that gives me the significance value. However, there are positives to the way that I had originally done it, the longer way of converting to a numeric variable of region and applying value labels. With this checkbox option, it only gives me the significance value. If I have an alpha value of 20%, like what I did before, then that would be significant. This would tell me that one of the groups is different from the other, but it wouldn't tell me which group. And that is why the Anova test before was helpful, because it came with these post-hoc tests, such that if it was significant, then I would also know which one. So you do more work and you get better rewarded for it. I'm going to go and save my syntax. Still on this, same thing. Looking at my output, imagine what the average of the Western region and what the total average would be if that huge, huge value of 275 was excluded from the data set. That's right, I'm coming back to it. I'm coming back to cleaning my data set and removing this outlier. It's a very common statistics procedure. I go to my data set, and before I get ahead of myself, I actually want to save this data set. It's thankfully the folder that I was working with was pre-selected. I want to assign the name of this data set original. And I like to have an original copy of my data set, one that's pretty much untouched. Well, I did add a variable to this data set, but whatever. I didn't remove anything. And that's what I'm about to do. I'm about to remove one row, one outlier. And what I just did was I saved my data set, pasted the commands, and ran the pasted commands. So now original data set saved. To create a subset of this data, I go to Data menu, all the way to the bottom, select cases. And right now, the pre-filled in option is to select everything. Well, that doesn't help me. I want to select cases if a condition is satisfied. And then I click on the if button. Well, I know that the highest value is 275 from looking at the data set. And I want that value removed. Let's just say that any value above 230 I'll consider as an upper outlier, and I want it removed from my data set. I bring unit cost over and I say less than 230. I press continue, And this time, I always like to choose this second option for copy the selected cases to a new data set. That's exactly why I had saved my data set beforehand. I like having an original, untouched version of the data. Now I'm about to remove an observation. What if I didn't mean to do that? I don't want to take the chance of messing with a data set that maybe after I make the mistake, I realize, oh crap, I didn't want to do that. But I'll call this new data set outliers rem for outliers removed. And I'll press OK just to remind myself that to see if it worked. And you see a new tab opened up, new data set. It doesn't have a name, Untitled 3. I'd have to save it as another name. I want to check out, all right, analyze. Let's look at the descriptive statistics again. For the unit cost, I want to make sure that the maximum's in there. It is. This will let me know if 275 has been removed or not. And it has. As the maximum isn't 275 anymore, it's 125. And before we had 43 rows, now we have 42. How will this affect the data set, the Western region specifically? Before I proceed, you notice that when I open up these tabs, I'm starting to get more clutter. I have another data set here, and I'll probably have a couple more by the end of this. This little red X in the upper left-hand corner of the SPSS logo lets me know that that data set is active. Anything I highlight and run in this syntax editor will be applied to the data set with the red check, to the active data set. I remember, I'll go back to my original data set because that is where I applied the select cases. I want that command to be included in my syntax editor. SPSS remembers the last time in this SPSS session command I did. So I paste it. It says that data set's already named. I say whatever. And, I add my comments. Save data set. Remove upper outliers. And I want to make sure that this data set with the outliers removed is activated. And I was coming back to the Anova test, or the averages based off of the switch, removing that high value. I don't think I need to do all of the Anova tests this time. I select unit cost. I put in the region. I'll check the box for Anova test, but I'm pretty sure that it is going to be not significant, not even at a 20% level this time. I want to press OK, mainly to just see the change. And look at that. The Western region only had 6 observations to begin with, so one of them being so large really had an influence. We dropped from 53 of an average all the way down to 9. And the maximum value is now 20. And it's amazing to see also that just one value out of almost 50 caused the total average to increase by 20 points. It was 20 before, now it's 14. And I see the significance test of the Anova test. Now it is 50%, twice as large, more than twice, than it was with that outlier included in the data set. I want to make sure that that gets included into my, into my script file. So I paste it. And I might want to recall Oh, here we go. It included it. This data set activated. Now that I have more than one data set, whenever I'm running commands, it's a good idea to include that above each command. So SPSS knows or that it's not running procedures on the incorrect data set. Okay, what shall I do next? I think I'm going to proceed with a regression equation. And what I'll do is I'll attempt to predict the total based off of the unit cost. I'm sticking with unit cost. And right now I'm in my original data set. And prior to doing this Anova test, there's always some conditions that need to be checked. I'll examine some of these conditions, mostly a scatter plot, the relationship, if there's a linear relationship, and that's it. So I go to graphs, legacy dialogues, all the way down, to scatter plot at the bottom. I'll take a simple scatter. My x-axis, or y-axis rather, will be the total, my dependent variable, and the x-axis will be my independent variable, the unit cost. I can apply a title to the graph or titles to the axes, but I just want to look at the distribution. I'm not really trying to be neat right here. If I press OK, in my output window will be the scatter plot. And it doesn't look great. And I'll tell you why. I had done this data set on the original data set. Still has this super high outlier of 275. But what looks like two values also at 125 appear to be skewing the data to the right as well, and certainly messing up with this histogram or scatter plot. So similar to that very high outlier, just for this regression equation, I'm going to remove those 3 points and just predict total based off the unit cost of these values that are leftmost. And when I make this change, this subset, I think you'll notice a difference in the way the graph looks and the way that the regression equation would look. But just to build off of this while I'm at it, I'll go to Analyze and Correlate in Bivariate to compare the unit cost and the total. This is another thing I prefer to do prior to nothing in this section that I want to see. Prior to doing a regression equation, what is the linear relationship? And here we are presented with unit cost intersected with total provides 0.210. And I like to convert these numbers to percent. So 21%. That's not good. A correlation coefficient is always between the values of -1 and 1. The closer the value is to 1 or -1, the stronger the linear relationship. So values from -0.7 to -0.9 are typically referred to as strong negative linear relationships. Values from 0.3 to 0.5 would be considered as moderately strong positive linear relationships. And anything with a correlation below 0.3 or below -0.3 would be considered a weak linear relationship. The closer the value is to 0, the weaker the linear relationship. And with 21%, I have very little confidence that I could draw a line to best predict the total based off the unit cost. So I'm going to proceed with removing those 3 values, just like I'd done before. Data, select cases, and I'll just change my if condition. Instead of being 230, Any value that's less than 100. We'll keep those ones. And I'll call this new data set regression underscore prep. I press OK. And I want to quickly jump to my output window. I'm getting a little out of hand of my commands here. I want to add them to my syntax window. So I flag down my graph command, I copy it, and I'm pasting it into my syntax. And I want that correlate command as well, which I can find in the sidebar here. Lately, I've just been navigating and kind of getting lucky finding the correct code, but I can click on correlations over here, and it brings me right to where I want to be. Correlations, I copy that, and I'll paste that to my syntax window as well. Ha ha ha. And one more time, but this time I'll use the paste option. I'll open up my original data set because I did that select cases. It's already pre-saved in the history, so I'll paste it to my syntax. And now I want to make sure to activate this regression prep data set because when I create a graph this time, I want it to be with those values out. So same thing, graph, scatterplot. The x-axis is unit cost, the total is the y. And let's see a look, to see if it's different. The graph looks better. Now, another kind of condition, something that I'm wary of, especially in regression equations, is the way these values start so close and then fan out as we get wider. That's kind of a red flag, but I'm just doing this for the sake of demonstration. So I will continue with the regression equation. It looks a heck of a lot better than before. I bring up my data set, and I want to look at the correlations as well. I really want to see how that changed. Before it was 21%. I make sure unit cost and total are selected, and I proceed through there. Now the result is 0.73 when rounded up. It went from weak linear relationship to moderately strong positive linear relationship. Talk about a change. I want to add that to my syntax. And I'm ready to do the regression. I select my correct data set. I go to Analyze. If I were to take a guess, probably regression. And linear regression. My dependent variable, just like the y-axis, is total. My independent variables, just one variable this time, unit cost. Let's look at the statistics here. Yeah, that seems good. I'll leave the defaults. I'll include the descriptive statistics though. For the plots, I do like doing plots. So I'll have the dependent variable on the y and the predicted values on the x-axis. So that will show me how far off with the regression equation. In this case, a linear regression equation is a line. So how far off is the actual value from the predicted value based off the equation on a given set of unit cost? And I'll do the same thing with the residual and the dependent variable as well. And ooh, standardized residual plots. I'll have a histogram. That looks good. And this is if I wanted to save values, save the regression equation as aspects. That's kind of cool. But no, not this time. I think I'm ready. I press OK. and I look at my output, here's this R value. Again, 0.73 rounded, the same as my correlation coefficient. And this R squared value is also another measure of linear spread. Tells me that about 50% of the variance in the total variable can be described by the unit cost variable. And right here is where I have my equation. And I'm actually going to, well, I'll double click in here. Whoa, maybe not. And I'll highlight this output. I want to put it into my syntax window just as a reference before I analyze this. Oh, but first I want to include my regression equation into this syntax. I paste it. And here's the output. I make sure to add an asterisk where it is all needed so I can comment everything out. And from this information, I would create a regression equation that is total is equal to 40.041 plus 46.878 times whatever the unit cost is. This value of almost 47 tells me that per one increase in for $1 increase in unit cost, the total will increase by almost $50. And this value of 40 tells me if unit cost is equal to 0, which isn't really possible, but if it is, then it will have a total of 40. That's called the y-intercept. I'm not done yet. There's still a few more features that I want to talk about regarding SPSS before I finish up. I want to make sure to file and save my work. I also want to save these data sets too. Make sure I'll call this outliers removed. And I'll call this one regression prep, just like I had. Now, those are SPSS data sets. And I started with an Excel spreadsheet, and now I'm gonna finish with one. I want my data set with this one, the regression prep data set. I go to File, I go to Export Excel Data, and the other types of data then I can export to. It's already got the name, it's got everything the way I like it. I'm going to include that option, save the value labels, so that region _n looks like east, central, and west, but still contains the numbers. And one final thing before leaving, I didn't inspect actually these residuals or predicted values. So for the predicted values, ideally you want them closer to 0. The closer to 0 means that the regression equation was accurate, was a good depiction of the data. The further away from 0, that means, well, those observations were pretty far away from what we predicted with the equation. And similar with this residuals plot, you usually want a bunch of values scattered around 0. Now, I have all of this output, and before I had exported it to be of a Word file in case I wanted to create my own syntax, or in case I wanted to send this to somebody. And I want to finish with that. So I have my output file selected, go to File, and it says Export as a web report. I thought earlier when I did this, I had the option to export as a Word file. And the issue why I don't have that right now is because this coefficients box is selected, meaning that the settings of the file are different. When I click out of it, now I have the option of export and a bunch of other menu items. I want to export this as a Word file. I'll call it output end for the ending output. I press OK. I make sure that my syntax file was saved, as that has been keeping track of all of my work. Of course, so is the output file that I just exported as well. So again, there are multiple ways to accomplish the same task in programming. Thank you very much for attending. And if you have any questions, please write to our help desk, sizer@cornell.edu.